Last episode, we talked about LLMs, large language models, the text predictors, the autocomplete on steroids. But here's the thing, that's like learning about guitars and thinking you understand all of music. LLMs are one instrument. The AI orchestra, it's massive, and every section sounds completely different. Today we're mapping out the entire AI landscape, every major type of AI, what it does, how it works, in plain English. I'm Keith, welcome back to NeuralKeith. Let's zoom out. Before we get into the different types of AI, we need to talk about the engine under the hood of almost all of them, the transformer. Remember from last episode, we talked about how LLMs learn patterns from text? Well, the transformer is the architecture, the blueprint that makes that possible. And not just for text. This thing came out of Google in 2017, one research paper, and it basically changed everything. Okay, here's how to think about it. Imagine you're reading a book, but instead of reading word by word, left to right, like a normal person, you could look at every word on the page at the same time and instantly understand how they all relate to each other. The word it on line 15, you immediately know it refers to the cat from line 3. That's what transformers do. They use something called attention, and that's literally what the original paper was called. Attention is all you need to figure out which parts of the input are most relevant to each other. Before transformers, AI had to process things step by step, sequentially, slowly. Transformers process everything in parallel. And that one change, that unlocked basically the entire modern AI revolution. LLMs, built on transformers, image generators, transformers in there too, audio AI, yep, video AI, you guessed it, it's the foundation. Everything else we talk about today is built on top of this idea, or works alongside it. Alright, let's talk about the AI art revolution. Diffusion models. You've seen these. Mid-Journey, Stable Diffusion, DALL-E. You type in words and out comes an image that looks like a professional artist spent hours on it. But how? How does text become a picture? Okay, imagine you've got a TV showing pure static, just random noise, snow. Now imagine someone told you there's a picture of a cat hidden in this static, and your job is to slowly, carefully remove the noise, grain by grain, until the cat appears. That's literally what a diffusion model does. It starts with random noise, and it's been trained to remove that noise, step by step, until a coherent image emerges. But here's the clever part. During training, the AI learned to do this in reverse first. You take millions of real images, photos, paintings, whatever, and you gradually add noise to them until they're just static. The AI learns that process. Then you teach it to go backwards, noise to image. And the text part? That's where transformers come back in. The text prompt gets encoded and it basically guides the denoising process. It's like giving the AI a map that says, the cat should go here, and it should be orange, and it should be sitting on a spaceship. What blows my mind is that these models don't store images. There's no database of cat pictures it's copying from. It learned what cats look like, what spaceships look like, what sitting looks like, and it constructs something entirely new every single time. Now here's where things get really interesting. Remember from last episode, LLMs handle text, diffusion models handle images, speech models handle audio. They each have their lane. Multimodal AI says, forget the lanes. Models like GPT-4o, Gemini, and Claude can look at an image and read text and listen to audio, sometimes all at once. They're not just language models anymore, they're everything models. You can show GPT-4o a photo of your fridge and say, what can I cook with this? And it'll look at the ingredients and give you a recipe. You can show Claude a screenshot of a bug in your code and it'll read the error message right out of the image. You can talk to Gemini out loud and it responds with its own voice in real time. This is the direction everything is heading. The walls between text, images, audio, and video are coming down. The future isn't specialized models doing one thing, it's unified models that understand all of it. And the wild part? We're still early. The multimodal models we have now are like the first smartphones. Impressive, but you can feel how much room there is to grow. Okay, let's speed round through the rest of the AI landscape because there is a lot more going on. Speech to text. Models like OpenAI's Whisper can listen to audio and transcribe it into text with scary accuracy. Multiple languages, accents, background noise, doesn't matter. This is how your voice assistant understands you, how podcasts get auto-transcribed, how YouTube generates captions. Text-to-speech, the reverse. Give AI text, it speaks it out loud. And not the robotic voice from 2010. We're talking voices that sound genuinely human. 11 Labs, Bark, Chatterbox. You can clone a voice from a few seconds of audio. The implications are, let's say, significant computer vision. AI that sees, object detection, drawing boxes around things in images, facial recognition, medical imaging, AI finding tumors in x-rays that doctors missed, self-driving cars reading road signs and spotting pedestrians. This field has been around longer than most people realize, and it's everywhere. Reinforcement learning. This is AI that learns by doing, not from text, not from images, from experience. Trial and error. It tries something, gets a reward or a punishment, and adjusts. This is how DeepMind's AlphaGo beat the world champion at Go, how AI learned to play Atari games better than humans, how robots learn to walk. And remember RLHF from last episode, reinforcement learning from human feedback? That's this technique applied to fine-tuning LLMs. It all connects. Video generation, the newest frontier, OpenAI's Sora, Runway, Kling, AI that generates actual video from a text description. It's basically diffusion models cranked up to 11, generating not just one image, but dozens of coherent frames per second. It's still early, still a bit wobbly, but it's improving fast. Okay, let's zoom all the way out. You've got transformers as the foundation, LLMs for text, diffusion models for images, multimodal models bridging everything together, speech to text and text to speech for audio, computer vision for understanding the visual world, reinforcement learning for decision-making and robotics, video generation combining all of the above. Here's the thing that I think most people miss. These aren't separate technologies going in different directions. They're converging. The same attention mechanism that helps an LLM understand a sentence helps a diffusion model understand a prompt. The same training techniques that make ChatGPT helpful make image models more accurate. Speech, text, images, video, the lines are blurring, and that is why understanding the landscape matters. When you see a new AI product launch, you'll know what's actually under the hood. When someone says, "This changes everything," you'll know if it actually does. You're not just a user anymore, you're someone who understands the map. So now you know what's out there. Next question is, where does all this actually run? In the cloud? On your computer? On your phone? Next episode, we're diving into local versus cloud AI. The costs, the privacy trade-offs, the performance differences, and why running AI on your own hardware is becoming a real option for regular people, not just tech companies. Trust me, that one's going to change how you think about using AI entirely. If this episode helped you see the bigger picture, hit subscribe. We're building real AI literacy here, 2 videos a week. Drop a comment. Which type of AI blows your mind the most? Personally, video generation keeps me up at night, in a good way. Mostly, stay neural.